So hello everyone. In the previous class we have discussed about the hosting system, their numerical and their component, right? And we have done some derivation related to that hosting system, right? We have also solved the numerical, right? So the today we are going to discuss one of the another major component of the drilling rig, that is circulating system, right? So what is the need of this circulating system? The first question arise in the mind, what is the need of this circulating system, right? So as a human we required a blood, right, to flow in the body. So same thing, we required a drilling fluid to circulate inside the wellbore. We will talk about the function of drilling fluid also. So let's talk about the major thing, the major function of the circulating system to remove the rock cuttings from the hole as drilling progresses. What does it mean by simply, when this drill bit is rotating, right, it's generates some cuttings, and that cutting must bring to the surface. So we required some force to carry this cutting from the subsurface to the surface, and that force is provided by the circulating system through the drilling fluid, right? So I hope you are able to understand what does it means by, means the when the drill bit is rotating, right, when the drill bit is rotating, it's generate cuttings. That cutting could be small particles of the rocks, some mud, some shell, some another types of, and if this mud, if these cuttings are not able to come to the surface, then what will happen? It will accumulate it at the base, and when it is accumulated at the base, at that time what will happen? Your drill pipe or drill string is going to stuck. So we want to remove this drill cutting which is generated by the drill bit. We want to remove this drill cutting which is generated by the drill bit, and that is removed by the circulating system through the drilling fluids. Okay, so that is the basic function of the, that is the major function of the drilling fluid circulating system, to remove the rock cutting. So now let's understand that how this thing is working. So this is the pictorial diagram of the circulating system. We will going to understand. So this is the mud tank, right? This is the your mud tank through where the drilling fluid or any kind of mud is prepared. Through the mud tank there is a mud mixture is there, right? There is a mud mixture is there, and this is we call mud pump, right? We will discuss about the mud pump, what are the type of mud pump they have, we are going to use. This is through the mud pump. It's there is some cylindrical device, we will talk, so don't worry. It suck the fluid from this mud tank, right? It suck the fluid from the mud tank and discharge. This is the discharge line, and this is the standpipe, right? This is the discharge line through the standpipe. Then it is goes to the rotatory hose, to the swivel, then the Kelly, then drill pipe, right? Through the drill pipe, this through the drill bit, through the nozzle, then through the annulus. Let me change the color. Through the annulus, it's returned back to the return line. This is return line, right? This is return line. Through the return line, through the it's reach at point of the cell shaker, where we will discuss about this thing also. So through the cell shaker there is another where the large particle is going to remove. Then there is a descender where the sand is removed. Then there is desalter and degasser, and finally it's reached to the mud pit, right? This is how the whole function is working for the circulating system. I hope you are able to understand how the circulating system is working, right, and what is their basic function, right? So let's move to the another slides. if you're going to the another slide, you will find that this is the flow chart, right? I have prepared the flow chart. This flow chart is basically of the circulating system. What does it means? Means I have categorized this flow chart into the four component. Means the surface pumping system, downhole flow, annular return flow, and solid contamination, right? So initially what happened, initially the mud mixer mix the some amount of water, some polymer, some clay, right? This is the basic function of the mud mixture. After the mud mixture is goes through the mud pump, then it is standpipe, then it is rotatory hose, then it is gooseneck through the swivel to Kelly, and these when it is come to the Kelly, this comes under the downhole flow, right? Means the downhole flow. Then there is a drill pipe, right? Then through the drill collar, and there is a bit nozzle. Through the bit nozzle, we have discussed that there is a annular, right? The space between the drill pipe and the wellbore, that a space is called annular, right? And through the annular around the drill collar, then it is the annular around the drill pipe, which is open hole. Now next thing, the annular around the drill pipe, closed hole, and then it is casing returns or return lines, we can say. And through the returns line, it's come to the cell shaker, where the large cuttings is removed. Then there is a salting tank, there is a fine solid separation is there. Then there is a desalter or descender or desalter, hydrocyclone, where the as per the requirement we will use. And there is again the mud mixture, right? Property restoration, we will send this thing in the mud mixture. Then the suction tank, then this process is repeat. So I have missed the one of the important concept over here. If you observe carefully in this diagram, so this standpipe is here, right? And this is the rotatory hose, this is the rubber kind of things. So my question is that why don't they have used standpipe like us to flow the drilling fluid directly to the swivel or gooseneck? Why they have used the rubber type of things? The only thing is there, when the drill sting is rotating, right? When their drill sting are rotating, they are very flexible, right? They are flexible, and you can move anywhere, right? But when you use the standpipe of things like a rigid pipe, so that will be not going to help you, right? So that is why they use rotatory hose, right? A rubber kind of pipe over here. So now let me discuss about the important component of the principal component, you can say principal component of the rig circulating system. What are the principal component? As I discussed, there is a mud pump. The basic function of the mud pump is to provide the necessary pressure. The basic function of the mud pump is provide the necessary pressure and flow rate to circulate the drilling fluid down the drill sting and back to the surface. What does it mean by the necessary pressure, right? When the cuttings are generated at the bottom, right, and these cuttings are the heaviest part, let's say some weight of the cutting is there, so it cannot come to the surface through its own, so it required a pressure, and that pressure is generated by the mud pump, right? That pressure is generated by the mud pump. Through the drilling fluid, they try to lift the cutting, the small particles, and that is the lifting process is only done just because of they having some kind of pressure. Without pressure, they cannot move against the gravity, right? If you want to move against the gravity, you require some pressure, right? So I hope you are able to understand this thing. Then the next component is the mud pit, right? Mud pit is basically a store and the condition of the drilling fluid. Multiple pit are used for a different stage of the mud different stage of the mud circulating process. So mud pit is basically where the drilling fluid comes and the store, and that where there is condition is examined, whether they have lost their property and what are the contamination they have reached when it comes in the contact with the what you call the cuttings, and the other if the forging particles are there or forging fluids are there. So this is how the mud pit, these basic things. Now next in the mud mixing equipment. So we required a mixing equipment to mix the additives with water or additives with oil or many things. So this is the blend water, right? You add additive, you add some chemical to prepare the drilling fluid with the required properties. If you want to prepare a drilling fluid which having some required property, like you want to you want some kind of a mud which that mud having some kind of property, means apparent viscosity, rheological properties. So the mixing is very important process, because polymer are stick when it's come in contact with the water, they create a lumps, right? To create that lumps can be you can say disperse, or that can be mix with the water uniformly through the mud mixer, right? Then another major component are, that is the contaminant removal. Contaminant removal means the when the drilling fluid is coming return back to the surface, at that time there are some drill cuttings are there, right? That drill cuttings we need to separate, we cannot dump it, because in through the drill cuttings there are some toxic element are also coming, like some hydrocarbon is there, like H2S is there, some any other forging particles, like so they will harm. So we need to separate that particular part, right, to remove the drill cutting and other contaminate from the drilling fluid to maintain the effectiveness, right? So we want to remove the whatever the drill cuttings which is coming through the formation, or you can say coming from the subsurface, that is going to remove through the contamination removal equipment. We will talk about the what are the equipments we are going to use. Yes, so I hope you are able to understand. If you are not watched my previous video, go there and watch. There is a playlist of drilling engineering, right? Next thing is the mud pump, right? The everything is depend upon the mud pump, right? So mud pump is basically categorized into the two types, right? That two types is basically, one is the reciprocating pump and another one is the circulating pump, right? So which pump we are going to use, in this case we will going to discuss. And so if you required a high power low discharge, high pressure low discharge, in that case we use reciprocating pump, whereas if you required a high discharge low pressure, in that case we use centrifugal pump. So what is the meaning of the reciprocating and the centrifugal pump, right? Let me discuss. Okay, so if you are generating the pressure through the circular motion, that comes under the centrifugal pump, right? And if you are generating the pressure through the reciprocating, means the backward movement, that comes under the reciprocating, right? So as I told you, there are two types of pump are there, centrifugal pump and the reciprocating pump. And basic function of the circular, when you required a low discharge and the high pressure, in that condition we use reciprocating pump, whereas when you required a low pressure high discharge, in that case we use centrifugal pump. So in drilling engineering we mainly use reciprocating pump, we do not use circulating pump, right? So we don't want to discuss anything about the reciprocating pump, centrifugal pump. We will only talk about the reciprocating pump. Okay, so with the experience of the several with the expense of a several example types mud pump always have used, reciprocating pump is they used, right? With the experience they are used reciprocating pump. That reciprocating pump is called positive displacement pump, right? Positive displacement piston it is also called, and it is also called positive displacement pump, right? So these pump, positive displacement pump or reciprocating pump, it is divided into the two types, right? Double cylinder it is called duplex pump, and the triple cylinder it is called triplex pump. Don't worry about, I will discuss each and everything in details. Just for here in this slide, just remember this thing. There are two types of pump, duplex and there is a triplex pump, right? So the both the cylinder is called duplex and the three cylinder is called triplex pump are commonly, right? The duplex pump is generally double acting pump that pump on both forward and the backward motion, backward stroke. We will talk about they will pump the fluid from, they are saying that the forward, when the piston is moving from the left to right, they pump the fluid, right? And when they are moving backward, in that case they are also taking the sucking the fluid and discharging somewhere, anywhere they are required, right? So this is how the meaning of this forward and the backward piston stroke, right? Next one is the triplex pump, as it is called, we also call single acting pump, right? Whenever in this case single acting pump means triplex pump, double acting pump means the duplex pump, right? Triplex pump is generally single acting, that pump only have forward motion, forward stroke. Forward stroke means when from they are moving from the left to right, that stroke is called forward stroke. So don't worry about it, we will talk about what is forward stroke and what is stroke is called. When the piston moving from the TDC top dead center to BDC, the distance traveled by the TDC to BDC is called stroke, right? Stroke length. Okay, so now duplex pump, double acting pump, that pump on both the forward and the backward piston as I discussed, right? Triplex pump single acting, they pump the fluid from the forward stroke also, forward stroke only. The triplex pump are lighter. If you want to compare these two things, like a triplex pump are lighter and more compact than the duplex pump, right? Compact means that their size will be lesser comparatively to the duplex pump. Their output pressure are not as a greater, and they are cheaper to operate, right? For this reason, majority of a new pump begin replace into the operation are triplex design, right? So triplex design means the 3 cylinder, duplex design means the 2 cylinder, right? So let's talk about the some another reciprocating positive displacement pump, right? Advantage, overall efficiency, what is there, right? So yeah, this case the advantage, if you talk about the ability to move higher solid content fluid loaded with the abrasion, right? These are the advantage. Ability to pump the large particle, which is true. Easy to operate and maintain, and it is reliable. Ability to operate the wide range of the pressure, as I told you that the reciprocating generate more pressure comparative to the centrifugal pump. Overall efficiency, if you talk about the overall efficiency of a mud circulating pump is the product of the mechanical efficiency and the volumetric efficiency we will talk about, right? The mechanical efficiency usually assumed to means in the question when you are solving the question, in that case if the mechanical efficiency is not mentioned, in that case you can assume that the 90%, right, it is related to the efficiency of the prime mover, right. And the volumetric efficiency of the pump whose suction is adequate charge can be as higher as 100%. So right, what does it means by in the question if something is not mentioned about the volumetric efficiency, you can consider that the volumetric efficiency is equal to 1 or you can say 100%, right. The most of the manufacturing table rate the pump using the mechanical efficiency, which is represented by EM, and the volumetric efficiency EV, right. Now pump installation on the rig. Generally two circulating pump are installed on the rig. So how many pumps are installed on the rig? Two pump, right. Two circulating pump are installed on the rig. For the larger hole size used for the shallow portion of the most of the well, both pump can be operating in the parallel to deliver the large flow rate required, right. On the deeper portion of the well, only one pump is needed and second pump are serve as a standby for any pump maintenance is required. So what they are saying that when you are going to drill the well at a depth of shallow depth, in that case both pump are in the operating condition, means both the pump are operating. Why they are operating in the both the cases? Because they required a larger discharge, like large hole size, right. They required a large flow rate is required. But when they are going to drill the well which is having deeper depth, in that case what they do, they basically try to use only one pump and the other pump is keep it as a standby, because in any case one pump is lost or any maintenance is required in the first pump, they can use the second pump. As I told you, in generally two circulating pump installed on the rig side, right. So before jumping into this diagram, I tell you some clear picture, right. Let me draw through the hand so that you can understand what does it means by the single acting pump, right. So then I will explain the other part, right. So yeah, let's suppose this is your cylinder, right. This is your cylinder, this is your plunger, right, and this is your piston rod, right. So yeah, and let's assume that there is a sump means you can say the kind of things having a large amount of the water over here, right. Consider, if you want to understand the mechanism of this, right, if you want to understand the mechanism, and this thing is further connected with the other parts we will talk about, don't worry about it, right. This is how the things are there, right. These are the things, right. So just consider as a needle means a syringe when you go to the doctor when you are ill, in that condition they put some injection, right. So what they dip the injection into the liquid and try to suck. When they are trying to suck inside the injection, some amount of the fluid will come and that fluid is going to penetrate your body wherever it is required. It's simple. So what happened there? So when they are as I am assuming that this is the forward motion and this is the backward motion, right. So when their fluid is this piston cylinder device, this is the cylinder and this is the piston connecting rod. So when they are moving backward direction, means let's suppose now its position is here, right. So in that case what happened, it's create a vacuum over here, right, and there is a atmospheric pressure, P atmospheric pressure over here, right. So when they are moving backward, it's create a vacuum over here. So we know that P atmospheric is greater than the P vacuum pressure, right? We know this thing. So what happened, the basic mechanism of the pressure is pressure always flow from the higher pressure, which is this higher pressure, toward the lower pressure. So direction of the flow will be this side, right? So P atmospheric is equal to is toward the P vacuum, right? So all the fluids will start entering inside the this inside the inside this cylinder, right? All the fluid will start entering inside the cylinder, right? All the fluid will start entering inside the cylinder. And let's suppose now we are assuming that the piston position is here, right? The piston position is here. We will talk about there is some dia is there, there is a length of the cylinder is there. We will talk about, these are the mathematical expression we will talk about, so no worry about it, this thing, right? So what happened when all the fluid will start entering inside this piston, they will enter until when the P atmospheric is equal to P vacuum, right? I hope you can say, you can relate this thing, equilibrium condition, right? And now the fluid will, so there is a one, you can say the operating system is there, right? Now when all the fluids will fill inside the cylinder, this is going to block this thing, right? Simply. And now this, when the piston is now they have to push toward the forward. So when they are trying to push the forward, there is a valve which is going to open over here, and all the fluid is coming through this side, right? So this motion is coming forward, backward, forward, backward, forward, backward. You can assume that this is the T D, this is there, it is, you can assume that there is a this is T D C, top dead center, or you can assume over here B D C, bottom dead center, and this is the stroke, right? When the piston coming from the backward to forward, right? This is once, what happened, something wrong is happening, sorry, extremely sorry for this. We are here, we were discussing, okay, sorry. Yeah, this was your piston cylinder device we are talking about, right? And so this is the backward movement, this is the forward movement. As I told you, when the P atmospheric is greater than the P vacuum, right? In that case, what will happen, this fluid, the sum from through the sum, all the fluid will start entering. So this is how the mechanism is working, right? I hope you understand the basic fundamental things, how the pump is operating. So now jump to this part, right? Single acting design, right? So let me explain this thing. As I told you, this is called piston rod, right? This is the 3D image I wanted to show you, right? This is we call suction. Through this suction, fluid will enter inside this thing, and this is we call discharge, right? And this whole system is called, we are saying that this is the cylinder, and this device is called piston, right? And P1 is the suction pressure, P2 is the discharge pressure, and this is called, up to this is the length of the piston, or you can say length of the piston, and the length of the stroke. And D is the dia, this dia we are talking about. Right now here it is also some dia is there, right? We will talk about, right? So Here it is. If you are able to observe that this much amount of the fluid is entered over here, when they are started from this point, and when they have reached this point, now they will go forward and they will deliver all the fluid from there, discharge. And now again when they start moving backward, in this case, so this repetition is continuously happening, and this repetition is happening continuously, and right, so that he can deliver the fluid, discharge the fluid continuously, right? I hope you are able to understand about this thing. These are the different view of the pump. This is also different type of piston. If you say isometric external view, this piston cylinder is look like this. If you say the isometric cuttings view, when you cut this pipe in the two piece from the center, you will see that. So this is all about this thing, right? I hope you have learned something from this video. If you like this content, please don't forget to subscribe this channel. Okay, thank you everyone.